With this last video, we'll get into the most powerful concept of pointers, and that is pointers and functions, or function pointers. And this one can be fairly complex. It enables, a pointer function enables, or a function pointer enables concept such as called polymorphism, which is the ability to appear as several different methods. And you can use that in multitasking. So function pointers are great for multitasking, for function overloading, anything where you want to easily change a method of doing things. And so we'll demonstrate that in this presentation. So initially, we're going to go, as we go through the code, you're going to see these first two lines. And these first two lines are just what you've already seen in the past, which are a very terse definition of an addition function and a subtraction function. So the function addition simply takes two signed 16-bit integers and returns their sum. And the function subtraction takes two 16-bit integers and returns their difference. No big deal. We've seen this before. You could write that in your sleep. Line 5, it begins to get a little complex. In line 5, we're defining our pointer to a function. And this is the format of our function pointer. You start with the data type. And so in this case, we're going to say our function returns a signed 16-bit integer. Then we identify it as a function pointer, and we do that with the parentheses and the star, very similar to what we saw in that struct example with the dot notation. So the very same thing there. And so if you kind of remember that, that's an alternative form of structs. In this case, it's the same thing. You put a parentheses around the function name and add the star, and that now you've got a function pointer. And then you follow that the same way you do with the function. You follow that with the parameter list, with the data types of the parameter, and then preferably, you can leave them out, but it's preferable to have the parameter names there as well. And so in this case, we're just simply saying A and B, and they're the 16-bit data types that we would have in lines 1 and 2. So now we've defined our function pointer, and we've defined our functions. So how do we use them? Lines 8 and 9 will show us how to use them. So line 8, we're identifying that we want to use the addition function. So we say, very similar to what we used with arrays, we say the pointer to the function is equal to the address of the function. Very similar. In fact, it's identical to what we did with an array, where we said pointer to the array is equal to the address of the array. And if you use, same way, if you use the name of the function without parameters, it's going to return the address of that function. And so now we have the function we want to use in our function pointer. So what's left is to call the function. And so that's what we do here. Focus on this part right here, because this is how we call the function. Same way you would call it if it was a normal function. You provide the name and then the parameters. Now in this case, because we know it's returning a value, we've got to assign a data type to that value, which is int16. We're calling the results, and then we're calling the function with its form. And so it looks just like that, the same way we defined it, and that now calls the function. When we want to change to a different function, so then we print the results, and that's what you can see, and you see the output of the results. When we want to change to a different function, we have line 12. We say, okay, now we want to do a subtraction. So we say pfunct equals subtraction, and then results equals calling that function. So you have to break it down into 3 steps. So let me show those steps down here. You want to, step 1 is to set up the functions you're going to use, which are in lines 1 and 2, and then also your function pointer. So lines 1 and 2 are the functions we want to use, and then line 5 is our function pointer. And you've got to make sure that all of those data types align. Believe me, I made a mistake and it took me a while to find them all. Okay, so that's step 1. Then step 2 is you set the function pointer to the address of the desired function. I've got to change that. It's to the address of the desired function. How do we get that address? By simply naming the function without the parentheses, without its parameters, much like you do with an array. So it's the same exact format as setting a pointer to an array, except this time we're setting a function to a function pointer to a function. And then finally we call the function, and we do that by the same way you call an ordinary function. You say function name, parentheses, parameters, and then our arguments. And that's what we're doing here. And so we're calling it, call the function with the desired arguments in line 9. I recommend you go through that slowly. You might change some things and see what works and doesn't work, and then try writing your own.